Grignards do not only react with aldehydes to give the corresponding secondary alcohols. Grignards also react with ketones. Grignards also react with formaldehyde. So let's draw general representations of these reactions. So this is a ketone. That's a ketone. We can react this ketone with a Grignard reagents. And remember, Grignards are nucleophilic. They are also basic. That's because carbon bonded to magnesium is negatively polarized, if you like. There is a negative delta. That's because carbon is an nonmetal. Carbon pulls electrons toward itself, and that's the Mg bond, because carbon, again, is more electronegative than magnesium being a metal, obviously. So you take a ketone, you react it with a Grignard reagent. So what happens is that a tertiary alcohol is actually formed. And that R prime, this R prime, okay, comes from the corresponding Grignard. So this is a tertiary alcohol, and of course we get tertiary alcohol if we start with a ketone. Okay, so that's basically the reaction of ketones with Grignards in order to form the corresponding tertiary alcohol. Please notice that these two groups here are these two groups. In other words, these two groups come from the ketone, whereas this additional group comes from the Grignard. Grignard reagents also react with formaldehyde. So this is formaldehyde. If you react it with a Grignard, in general, of that formula, Grignard addition or nucleophilic addition takes place. Now, the two groups are H and H. Basically, these are only hydrogens, so the product is actually a primary alcohol. So the product that is produced is R prime coming from the Grignard that will attack, of course, that carbon. So this should be bonded to that carbon. Remember that carbon, okay, that one is basically that one. This carbon of the formaldehyde is actually that one, which gets attacked by the Grignard reagent. This is formaldehyde. And if formaldehyde reacts with the Grignard reagent, as in this case, the alcohol that's produced is a primary alcohol. So these two schemes now represent two additional reactions, if you like, or applications of the Grignard chemistry or the Grignard nucleophilic addition on carbonyl compounds. To conclude, after that, Grignards attack ketones to give the corresponding tertiary alcohol with more carbons, and the additional number of carbons comes from the Grignard. Grignard reagents also attack formaldehyde, or they add to formaldehyde in nucleophilic addition reaction to give the corresponding primary alcohol, and the additional increase in the number of carbon again comes from the corresponding Grignard. We've seen before that Grignards also react with aldehydes to give the corresponding secondary alcohol. Therefore, in conclusion now, we can actually make all kinds or all types of alcohols using the Grignard chemistry or utilizing nucleophilic addition reactions of Grignards on carbonyl compounds.